Hi everyone. Today we are going to learn about quantitative chemistry. In quantitative chemistry, we are going to deal with calculations involving mass, volume, concentration, and something new that you have not learned, which is mole. And this number here is a very special constant that has to do with mole. As a recap, let's look at the structure of an atom. An atom consists of protons, neutrons, and electrons. And the mass of proton is 1, neutron is 1, and for electron is 1 over 1840, which is close to 0. As we can see from the periodic table, the smaller number above the element represents the proton number, and the larger number represents the mass number, or sometimes we call it the nucleon number. Now, how do we measure the mass of an atom? In today's modern technology, we have advanced equipments like mass spectrometer, which can enable the measurement of an atom to be carried out. We want to look at the basic fundamental of measurements. Let's look at length as an example. Here we have 1 foot, and the rest of the measurements of length is being compared to 1 foot. And we can have, let's say, 2 feet. How about mass? For mass, we use carbon-12 as a reference, or we call it a standard. Now here is just extra information for your benefit on why carbon-12 was chosen as a standard. As you can see here, there are many good reasons here why carbon-12 is chosen. Some of you might think, why not hydrogen? Mainly it's because of the third reason, because carbon-12 exists as a solid. It can be handled easily. Now this is the comparison of mass using carbon-12. One carbon-12 atom has the same mass of 12 hydrogen atoms because carbon-12 has 6 protons and 6 neutrons, whereas one hydrogen has only 1 proton. We can also say one hydrogen atom has the mass of the 1/12 of one carbon-12 atom. This brings us to the definition of relative atomic mass. Relative atomic mass is the average mass of one atom of the element when compared with 1/12 of the mass of a carbon-12 atom. To put it plainly, as we have established just now, the mass of one hydrogen atom is the same as 1/12 of a carbon-12 atom. And we are interested to know how many times heavier is an atom as compared to just one hydrogen, or 1/12 of a carbon-12 atom. Let's look at this periodic table once again. Let's choose neon, for example. Neon is 20 times heavier as compared to one hydrogen atom, or we can say neon is 20 times heavier as compared to 1/12 of a carbon-12 atom. Which of these elements has a different relative atomic mass as compared to other elements? If you look carefully, chlorine has a relative atomic mass of 35.5. This is because of average mass is being taken here. Let's look at carbon again as an example. Carbon has 3 types of isotopes: carbon-12, carbon-13, and carbon-14. Because carbon-12 has a very high percentage, therefore the average mass of carbon is 12. But it is different for chlorine. Chlorine has 2 isotopes, chlorine-35 and chlorine-37. And chlorine 37 has a percentage of 75%, and chlorine 37 has 25%. So when we take the average mass, the mass of chlorine is 35.5. Now let's look at relative molecular mass. Relative molecular mass is similar to relative atomic mass, but now we are just dealing with molecules. And now we want to find the relative molecular mass of the following substances. Just for example, oxygen, it has a formula of O2, therefore the mass is 16 times 2, which is 32. Now I'd like you to do the following examples. You may pause the video for a while. Now please check your answers. And I would just like to explain number 5. For CH3COH, we have 2 carbons, 4 hydrogen and 2 oxygen. Therefore, the mass is 60. Next is relative formula mass. This is mainly for ionic compounds. For this exercise, I would like you to use the periodic table to find the relative atomic mass by yourself. Just an example for the first one, sodium chloride. Sodium has a mass of 23, chlorine has a mass of 35.5, so the relative formula mass is 58.5. Now you can pause the video for a while to complete the rest of the questions. Alright, now you may check the answers. I would just like to explain number 4 and 5. For number 4, you need to be very careful with this bracket here. Ammonium phosphate. That means there's 3 times of ammonium ion. If we calculate the number of atoms, we have 3 nitrogen, 12 hydrogen, 1 phosphorus, and 4 oxygen. So the relative formula mass is 149. The next one is copper 2 sulfate, hydrated copper 2 sulfate. This dot here, it means there's water present in the crystal. The calculations can be calculated separately. For copper sulfate is 160, and for 1 water molecule is 18, and there are 5 water molecules here. So in total, copper sulfate is 250. For the last part of this lesson, we want to find the percentage of a certain element present in a compound. For the first example, we want to find the percentage of calcium by mass in calcium carbonate. The first step, we find the relative formula mass of calcium carbonate, which is 100. Then we just use the mass of calcium, which is 40, divide over 100, and we will get the percentage of calcium is 40%. The second example, we want to find the mass percentage of nitrogen in ammonium sulfate. I would like you to pause the video for a while to calculate. Now let's check the answer. The answer is D. To show you the calculation, first we need to find the mass of ammonium sulfate, which is 132. Next, we need to be careful here. The mass of nitrogen present in ammonium sulfate is 28 because there are 2 nitrogen atoms present. So therefore, it's 28 over 132 multiplied by 100%, we will get 21.2%. And that's all for today's lesson.